All right, here's our fourth example, and our quadratic equation is x squared plus x is equal to 12. First step is to rewrite it so that it's equal to 0, and we're going to do that by subtracting 12 from both sides. So it's going to be x squared plus x minus 12 is equal to 0. All right. So what's our a? Our a is the coefficient in front of the x squared. That's a 1. Our b is the coefficient in front of x. That's also a 1. And our c is the constant at the end. That's the negative 12. So now we need to find the x-coordinate of the vertex. And so that is x is equal to negative b over 2a. And so that's going to be negative 1 over 2 times 1. It's going to be negative 1/2. Alright, so I'm going to use my negative 1/2 here as my x value for the center of my symmetry chart. And then, let's see, maybe, let's look at this equation. Okay, let's maybe do 2 units away. So it's negative 1/2 is here. I'm going to do negative 2. I could tell by this graph here that it's the parabola will look better if I space it out a bit. So my vertex is here at negative 1/2. I'm going to go to negative 2 and negative 5. Okay. So I'm going to go to negative 2 and negative 5. And then negative 7. So now I'm going to go to positive 1. Right. So I went this way to the left 1.5 times. So I went 1/2 and 1, right? So then I'm going to go to the right 1/2 and 1. So that's why I used the 1 here. And then from then on, I did, oh no, I used the wrong numbers here. I did minus 3 and minus 2. This is not right. This should be a minus 8 right here. I'm going to go minus 3. I'm going to go 3 units. So once I got to negative 2, I went 3 units that way, then 3 units that way. Right? So I'm going to go the same here. I'm here at 1. I'm going to go 3 units this way, that's 4. And 3 units that way, that's 7. So it's 4 and 7. And so when you fill out the x values in your chart, you just need to make sure that the amount of spaces that you're moving in this top section is the same as the amount of spaces you're moving in the bottom section. I wanted to make it look pretty, so I spaced it out a bit, right? But you could very easily have just gone minus 1 every single time and plus 1 every single time, right? Okay, so let's go ahead and calculate. So negative 8, oh no, this is going to be a beast. So we have negative 8 squared here is 64. Minus 8 is going to be 56. Minus 12 is 44. So it's 44. Okay, we're way off of the graph. All right, let's try negative 5. It's going to be 25. Minus 5 is 20. Minus 12 is 8. All right, we're finally getting onto the graph. Negative 2 is going to be positive 4. Minus 2 is 2. Minus 12 is negative 10. 4, 2, negative 10. Okay. And then negative 1/2. Oh no, we're gonna have to do some scratch paper here. So negative 1/2 squared minus 1/2 minus 12. So what is that gonna equal? So it's gonna become positive 1 over 4 minus 1/2 minus 12. And what is that gonna become? That's gonna be 1 over 4. And then we need to multiply this fraction by 2 over 2, right? So that the denominators can be the same. So that's going to be minus 2 over 4 minus 12. Alright, so that's going to equal to negative 1 over 4 minus 12. That's going to equal to negative 12 and 1/4. Okay, so since the signs are the same here, we add and keep the sign. It's going to be negative 12 over 4. Okay, so anyways, right here it's negative 12 and 1/4. And then from then on, we could just use the same values we used up here at the top. So it's negative 10, 8, and the great grand 44. So we're at negative 8 and it's positive 44. I'm not even going to draw it. It's so high up. Okay. Here we have negative 5 and it's positive 8. So maybe I can guesstimate the 8 to be right about there. Our negative 2 is going to be negative 10, so that's here. Our negative half is going to be negative 12 and a quarter. It's right there. And then 1 is going to be negative 10. Our 4 is going to be 8, which is going to be up here, guesstimated. Okay, sorry for this. I should probably have used negative 3, negative 4 instead of, yeah, I thought it was going to, the graph was going to turn out weird. But anyways, I'm going to go ahead and draw my parabola. Try to draw my parabola, like so. All right. Okay, so what are the roots of the quadratic equation? Well, I'm looking here at my table, and I can't find them, right? I'm looking here at my graph, and they don't look exact, right? It might be, it looks like a fractional number. So how can I find the roots of the quadratic equation if they're not in the chart? And in the graph, it's unclear, right? Well, what we can do is we can try to find our y, set our y equal to 0, and try to find our x. Okay. So in this case, it's going to be our original equation is y is equal to x squared plus x minus 12. All right. So what we want to find is when is y, what is x when y is equal to 0? So y is equal to 0. X is equal to x squared plus x minus 12. Now, if you're looking at this equation, your alarm bell should kind of be, your spidey senses should be tingling a bit. Because chapter 8, the previous chapter, we learned how to solve these, right? How did we solve this problem? We solved it and in the form x squared plus bx plus c is equal to 0. Okay, so how did we do that? We formed an x. We put our a times c, so it's going to be our c up at the top, so a times c up at the top. We have b at the bottom, right? And then we find our two factors. All right, so let's go ahead and do that, right? So a times c, or a is equal to 1, our b is equal to 1, and our c is equal to negative 12. Okay, so then our a times c is negative 12, and our b is 1. So what two numbers, and since our x squared has a coefficient of 1, we don't need to, well, we could put an x up here if we want. Okay, and so now what two factors, factor 1 and factor 2, multiply to negative 12, add to 1? Well, we need the factors of negative 12, so we have of 12, so it's 1 times 12. They do not add to negative 1, up to 1. We have 2 times 6, those don't add to 1. We have 3 times 4, yes, those add to 1 because our product is negative, which means one of these factors is going to be negative. So let's do 3 comma 4, right? Our product is negative, which means one of these factors is going to be negative. Our b is positive, which means our smaller factor is going to be negative. All right, so we found it. Now we're going to go ahead and factor. So let's go ahead and write our factors down. It's going to be x minus 3 and x plus 4 is equal to 0, right? Remember, we are factoring this polynomial here, and it's equal to 0. Right? We want to find out what is x when y is equal to 0. Right? So after we factored, we're substituting that factor those factors right in there, and it's equal to 0. All right, and that equal to 0 is so important because that allows us to use the zero product property and find out what is x in both the factors. So what does the zero product property tell us? That either this factor is equal to 0 or that factor is equal to 0 or both. So we can set them equal to 0. X minus 3 is equal to 0 and x plus 4 is equal to 0. We're going to add 3 on both sides in this case, and we get x is equal to positive 3. We're going to subtract 4 on both sides, and we're going to get x is equal to negative 4. So what are our answers here? It's x is equal to 3 or 4? Oh, let's put a box around that. Oh, and if we wanted to write our answers as ordered pairs, as we've been doing, right? Well, our first one is going to be x is 3 and y is 0. Right? Our second solution is going to be x is 4 and y is 0. Oh, I'm sorry, negative 4. Okay, so actually, we didn't need to go through all of this process if we had just used negative 4 in our chart.